Reverse Engineering, Part 2, Fuzzing and Instrumentation, a primer by Chris Davison and Joe Grassl. What does fuzz mean? It means hip slang for the cops. It is the greatest psychedelic hard rock band of the 21st century, in my opinion. And as it applies to us, it is a testing technique in security where lots of different inputs, often weird inputs, are thrown at an application, and we check out what happens. Next slide. So, web fuzzing. Let's check out content discovery, which is when you try to find hidden directories and files on a website where you wouldn't normally have access to them via hyperlinks. For this, what I like to use is a tool called FFUF, which stands for Fuzz Faster, you fool. It's the fastest web fuzzer that I've ever come across, and it is significantly faster than Dirbuster and GoBuster, so you can go ahead and upgrade to it. That's what I would suggest. Next slide. As you can see, the usage of it is fairly simple. You just need a URL. You need the fuzz keyword wherever you want the fuzzing strings to be injected. And then you need the number of threads and a word list. The word list I'm using is like absolutely massive. It's way overkill for real life, but it illustrates how fast this tool is, which is why I picked it. You can see we've got a hit on the directory API down below. Next slide. So then fuzzing on the API directory with the fuzz keyword up above you see, we get action.php as a hit, and we will browse to that. Next slide. Browsing to action.php, it says that it requires a parameter of some sort, which we can also fuzz for. Next slide. This is the default response of the last page that we were just on. The size of returns normally is 24, so we can filter that out to get whatever actually works. So you can see on the very end of the command, we have -fs24 to filter out the default response size. And we get a hit on the parameter reset. Next slide. So that worked, but now it's requiring some sort of account ID, and 1 didn't work. So we will create a word list of all the numbers from 1 to 999,999. Next slide. We can do that using another great tool I love called Crunch. It just generates word lists programmatically, however you specify, and it does so really fast. So there you can see the end of the word list, all the way up to 999,999. Next slide. This is the default response from FFUF of that last page we were on, where it said we need the account ID. So we can filter out size of 27. Next slide. And filtering out the default response, we eventually use the word list to obtain the only existing account ID, which is 20. Next slide. And that's it. We get the flag. So yeah, that's basically content discovery. Next slide. Next up, we have instrumentation, which is a bit different from fuzzing. Essentially, you are freezing an app, you're pausing it, you're injecting some code that you want to modify the behavior of the app somehow, and then you resume the app, upon which the modifications take place instantly. And there's many use cases for it, not all of them security related. Next slide. So the tool I'm using here for instrumentation is called Frida. It's pretty popular with security people, especially in the Android hacking community. And it uses an injected JavaScript server to run snippets of JavaScript code in real time. Next slide. This is our demo app. It's just trying to compare two strings that will never be equal by default. And it will return a response of result is 1, because in C, comparing two strings that are unequal returns 1. Next slide. And this is the code we are injecting into that app with Frida's Python API. And as you can see in the middle of the purple, we have retval.replace0, which is going to return a 0 for every instance of the function at the function address we supply to it. Next slide. This is a tool called Radar2. And it's basically like a giant glorified debugger. We're just using it here to simply obtain the function address of string comparison in C. Next slide. So once we have the string comparison function address, we give that to our exploit script running the instrumentation code, and we continue running the application from Radar2's debug mode. And initially, you can see the result is 1 because we haven't executed the script yet for the instrumentation. But as soon as we execute the instrumentation code, it switches to result is 0 because it's patching the string comparison to always be equal. Next slide.
Okay, the American Fuzzer Law. Fun facts is named after a type of bunny. Has the latest, most up-to-date and advanced UI. It's all in command line. Made by Michael Zalewaski. It's fast and smart and solid because it uses compile time instrumentation and genetic algorithms to find test cases that trigger new internal states. Probably crashes. My example, I use SecNote. I did SecNotes and I used wfuzz. What is wfuzz? It's a simple and brute forcing tool. You tell it what to do, you give it a big word list, and you just let it run. So what do we do? First, we have to connect to the VPN for Hack the Box. So you see me pinging a bunch to make sure I'm actually on. Then I went to the IP address, and what did I get? I got a login with username and password, and a sign up now. So just testing around, I made my own sign in called test1. Gave it the password of password. And as you can see, new note, change password. It's a secure notes program. Also see up there, there's some guy named Tyler who is the contact. So I know that's one potential avenue to attack. Just username Tyler. So let's get fuzzing. I use a SQL word list first to test for all the SQL commands that gave me different responses other than just no account found. And I also tested with all the usernames and a standard password of password. I found a couple, including Brooklyn and Tyler and another one, Dick. Well, off of somebody's recommendation on a forum, I tried a SQL injection by including the SQL command alongside the username. And I already knew Dick's password because when I got the response back, it gave me a redirecting response as opposed to just a different response that wasn't no user account found. So I got into Dick's secure notes. And with that, I found Mimi Sticky Buns, years, new site, test. And if I wanted to continue this hacking challenge, I would go to new site, which included another IP address, and I'd go to that IP address and I would continue down until I find the flag. But I'm not interested in that. Instead, I stole Mimi's Sticky Buns recipe, successfully hacked. And we used fuzzing to do it. Thank you all for watching. Okay.
All right. I think that went pretty well.